Hello, hi. And today we also get the honor again to have invited speaker from Advantech about the IoT solution architecture and software platform. And our speaker is Louis Lu, and now he is IoT architect director in Advantech. And he has over 20 years software engineering background and also expertise in assembly C, C#, etc., all these languages. And also, he has several patents related to IoT and critical handling application, and also work with our universities, iOS Center, and the National Jiao Tong University's the IoT lab. And in his career, he is one of pioneers to build the IoT solution architect for this industry. As you know, this industry is very new. I do remember last week, the Dr. Alan Young gave a talk about use the open source platform, and then like Advantech can work with so many different partners to form an ecosystem. And after that talk, actually we get email from Jill, and Jill asked a very smart question. That question is, if now Advantech set up a platform using open sources, why other firms, they just use open source to build their own platform rather than relying on Advantech? So Julie, this is your question. Yeah? And then our TA team and we spent some time to think one possible answer for why this platform strategy will work. And later Mr. Lu can justify this.
Yeah.
And the answer we come out is, if now you use your own platform using open source rather than relying on Advantech or other companies, you only collect data on your machine. And as you know, in the IoT and big data era, if you get smaller set of data, you cannot tune parameters better than the other players who have more data. Even you can use open sources, return IT to build your platform. In that case, you only get data on your own machine to tune your operational efficiency. But if you use Advantech or other players' platform, they can get more than the machines you have. So they get large volume data as Foxconn strategy. At the end, they give you better way to optimize your machine and the IoT equipment. So the true power from platform is not open source. It's to help the platform owner and the participants share the data to let each one better. If you use your own IT system to play, at the end, you may not be able to get competitive advantage because all other players using the platform strategy, their performance is better than you because they have more data. But this makes sense. Yes, so this is one, we spent some time to brainstorm this possible strategy why Advantech and Dr. Yang, they come out. And I do believe today Mr. Louis Lu can give us better answer because he is one pioneer in this area. So let's give applause to Mr. Lu.
Thank you, everyone. Since NTU gave me the chance to let me to present the latest Advantech IoT solution architecture and the software platform and the solution. So it's also, I will give you some of the idea about the latest our Advantech, the corporate, the strategy to deal with the new IoT solution. Okay, so before I start this session, I have to say today I have two challenges for me. First, I didn't know how much technical background you are, so I need to express the technical architect in the easy way to let you understand what I'm talking about. That's the first challenge. And the second challenge is, it is difficult for me to explain the whole IoT architect in Mandarin. Not mention I need to translate in English. So I do my best to translate the whole architectural and the technical side for you. Here, thanks Professor to introduce myself. My name is Louis Lu. Okay, I have been working at Advantech more than 10 years. Right now, let me describe that. I'm the highly experienced executive, the coach, and helping the leader software development in the different functionality. My teams and in the software development, and we are the tech in charge of a lot of the software, from the firmware to the driver to the operating system. Even now, we start to develop the cloud solution. And I'm facilitating different diverse IoT device adapted with the latest IoT standard technology. As you might know, the IoT standard is iterating in the last few years. So I need to start the latest IoT standard to try to find out the best solution and the best standard solution to adapt our latest IoT solution or to adapt to our wide path development. And I'm also the co-head of the Advantech IoT technical unit and play as the role of the chief IoT architect to design the technical for the Advantech IoT solution. And I'm also the leader of Taiwan and China in Xi'an and the outsourcing team around the 100 more R&D to coordinate each team to develop Advantech wide path solution. Here's my experience. I have been working in the software background around 20 more years. Here, my expertise is in the assembly, C and C#. And also include I have the 5 years in the chipset design and the firmware knowledge. Does anyone know the BIOS? I'm also as the BIOS engineer for the 10 years. BIOS is the kind of the middleware, and they have to well know the two aspects. First, they need to know the hardware behavior or the chipset behavior. Then they need to well know about the operating system and application behavior. Then the kinds of the engineer need as the bridge to communicate with the hardware and the software. So I'm the guy to know the hardware, software, driver, and even the cloud solution. Then I'm also as a participant in the NTU iOS Center and the NTU IoT Lab. Okay, let's take a look about the Advantech. Advantech was established in the 1983. Right now we are around 8,000 employees, and our revenue in the last year is around $100 million US dollar. We focus on the three major fields. First is the Industrial 4.0, and for the Industrial IoT. The next is the Smart City, specific to the medical, retail, and the logistics. The last one is the industrial equipment manufacturer, such as the huge machine maker or like the CNC machine. And our market position is the #1 for the IPC. Okay. And another honor for the Advantech. In the last year, Advantech was ranked at the #6 in the Best Taiwan Global Branding in 2017. In the Nikkei Asia, Advantech was the number 36 in Asia and the number 5 in Taiwan. In the top 100 industrial IoT company, Advantech is at the number 47. And last year we acquired the B plus B company. It was at the number 93. And for this part, as you can see, Advantech, the market share is the number one. We far beyond the second tier. Okay, let's get in the main topic. Here, I think the last time our CTO had to present the same slide, but I still remind that again. Here, for the Advantech perspective, we see the IoT growth have the three phases. First phase, we so-called the embedded platform. We was the established IoT product BU to provide the many kind of the embedded system and embedded platform to fulfill our customer application usage. Then we would like to get on the phase 2. So we was established a new department, so-called IoT Sense. The Sense is the full name is the Solution Enabled Service. And we also adjust our business unit to be the IoT Solution Business Unit. And now we would like to provide the more comprehensive software solution. So our Solution Business Unit, they would like to provide the so-called SRP, Solution Ready Package. Such a package is the software plus the hardware. And then they have to adapt on our WISE path. So we also provide another platform that is called WISE path. In the phase 2, so-called IoT integrated software platform. For the phase 1 and the phase 2, that is the Advantech core business. But in the phase 3, that is not the Advantech main focus. So Advantech established investment department, and we create a co-creation strategy. Then we invite the partner, the end application partner, and then through the co-creation strategy, we engage and empower some of the startup company, some of the data scientists. They can share their core competency in the data. But for the end application user, they have the domain know-how and they have their pain point need to fix up. So Advantech provide a solution ready package, and also we provide the platform to help such a provider put their solution under our platform. Then we also engage the end application user to provide their data and provide their pain point. We try to co-create through the co-creation strategy to empower such a startup company to be the IoT cloud service provider. Okay, so in this phase, Advantech plays as the enabler. Okay, so there are the key technical elements to influence the IoT development. So how the Advantech to deal with that in our corporate strategy and in our product division plan. The first one is a sensor. The second one is wireless networking. The third one is the cloud, include the IaaS and the PaaS. does anyone know the ICE and the PaaS? Everyone know that, right? Okay, so cloud include the ICE and PaaS and the SaaS. Okay, and last one is the big data analytic. Okay. Before I start to explain such the IoT solution architecture, I would like to give you the idea. We draw up the list architecture. Would like to help our frontline sales to express such the architecture to their customer to know what the Advantech strategy is. And then we would like to let our internal product division know what their product position is. So, and what kind of the product they need to communicate with. So, let me start to explain such the architecture. From bottom of this architecture, so-called IoT sensing device, we was established the open standard, so-called M2.com standard. Such a standard like the module, they can adopt the different wireless protocols, such as Wi-Fi, Bluetooth, DAS network, Sub-1G, LoRa, SIG-FAS, even now the most popular NB-IoT. So our others, the product division or our customer can based on such the module to produce their device and their housing for fulfill their vertical needs. For example, we have the product division dedicated for the medical. So their housing need to have the antibacterial. And some of the industrial sensing devices, their housing need to have the dust proof or the waterproof the design in their shelf. And, okay, in the second layer, so-called the embedded platform or the edge intelligence server. In this layer, Advantech was doing well in the last 13 years, but it's quite different in the past. The hardware we provide that. Why we call that the embedded edge intelligence server? It's quite different with the hardware system. We not only provide the IPC system with the operating system, but also we adopt a lot of the IoT related software stack, such as the sensor protocol, cloud protocol, and some of the intelligent software stack in our system. So the third layer is so-called solution-ready platform. That's our product division. They would like to provide more approaching their vertical customer needs. So they provide the combination with our edge device and the sensor device, but also they also include our software stack to provide the solution-ready platform, and then provide some of the application interface to more close our customer need, and to help our customer to easily to develop their application and their usage by our API. Then the top of this architecture, that is not the Advantech main focus. So as I just mentioned in the last slide, we through the co-creation the policy to empower our user, our partner. So we focus on the smart city solution, Industrial 4.0, and the IIoT solution. So for the vertical layer, it goes through the horizontal layers. The so-called white spots. White spots have the 4 key components. As you can see that we have the white spots edge sense, white spots video sense, web access, and the white spots NSAS. For the white spots edge sense, it's dedicated for the latest wireless sensor protocol aggregation. And we provide, I will give you more detail in the later on the slide. And we also provide some of the source code to help our customer to develop their own sensor device or develop their own application on the edge. Okay. Next is a video sense. For the industrial usage, there are a lot of the video applications, such as especially in the retail and in the smart city. So, such as the human detection, facial recognition, and also have the signage and video CMS. Okay, so the third part is the web access. Web access is the traditional equipment data aggregation. You might know the SCADA. SCADA is the quite old the standard. They aggregate the equipment data by the traditional protocol. So web access is the aggregate kinds of the equipment data, and like the CNC, like the other the vendor, like the elevator, to get traditional data to the cloud. Okay, and for the white spots NSAS. White spots NSAS, the full name is white spots enable SaaS. It's not a SaaS, it's the PaaS platform. It tries to enable the SaaS, empower the SaaS player. So white spots NSAS is based on the Microsoft Azure, the SaaS IaaS infrastructure, and we established the Cloud Foundry and leverage a lot of the near future like the IoT hub, elastic scaling, data analytic, and multi-tenant. I will give you a detail of that. Okay, from the bottom of our IoT architecture, as I just mentioned, we provide the open standard so-called M2.com. As you can see, the standard, we define the 3 major parts. First part is microprocessor. We collaborate with the ARM and some of the chipset vendors such as TI, ST, and NSP. And we also to partner with the ARM to provide the unified operating system for the microprocessor. They call that as the ARM embedded operating system. And the second part is the sensor interface. Sensor interface is the kinds of the interface. It leverages the M.2 interface. That is the existing interface for a long year. So we redesign that reserve pin and to leverage our sensor interface from the application board. So as you can see, such of the picture, this is the module board, or we call the RF board. Our customer need to develop the application board. Such an application board is their application to adopt a different sensor for their application, such as the vibration, temperature, or some of the GPIO to do the actuator. Okay. So The third part is a wireless connectivity. We also engage a lot of the RF vendor to adopt different kinds of the wireless protocol on the module board. So that's one is the most important one. We also collaborate with the sensor vendor, sensor chipset vendor. We would like to help them to develop their application board. So they can based on the M2.com standard to develop their application board and provide to their customer. So their customer can, based on such the application board, and choose what kind of RF protocol or the wireless protocol they need to adopt. So different RF protocol, different wireless protocol, they have a different purpose. Like the Wi-Fi, they have the high throughput. For the DAS network, it dedicated for the high availability, the transmission. Okay, LoRa and sub-1G and the CFast is the long range and the low power consumption. For the LTE, it's like you can leverage existing telecom station, so they don't need to extra the cost to build up the station. Okay. In the second layer, the so-called edge intelligence server. As you can see, we not only provide our hardware system, we also provide a combination of the software. We call that as the edge sense. Edge sense is the combination of the kinds of the software stack. So for the edge sense, we have the 5 major features. First is the data acquisition and the collation. And second is the sensor and the protocol management. For the edge sense, we would like to communicate with the different sensor protocols. So the protocol and the sensor management is must. They need to communicate with the different sensor protocol. Then that different protocol can communicate each other. The third one is the edge analytic. Some of the customers would like to do some sensor pre-process in the edge. That means we don't need to transmit all kinds of data to the cloud. Some of the data need to action and do some pre-process on the edge. Okay, so when some of the data need to pre-process and on the edge, so we have another benefit is a real-time reaction. So real-time reaction is when data the transfer to the gateway, they have the intelligence on the gateway to monitor the sensor status. Then when some of the status higher than the threshold, they will do some operation that is called real-time reaction. They don't need to transfer such the data to the cloud to make the decision. Okay. The last one is the cloud connection. So as you might know, the cloud connection, they have the different protocol like the MQTT, AMQP, and HTTP, and so on and so forth. So the cloud connection, they have to include the different library to communicate with a different cloud solution. Okay, based on the edge intelligence server, we provide 2 kinds of the software to help our customer to easily to develop their application. First one is called Voice Agent. Voice Agent is kind of the software can help customer to integrate kinds of the software in their device. So they can communicate with their sensor data and their application and send what they want the data to the cloud. Okay, so voice agent is kind of the open source code we put on the open source community, so customers can get such the source code to develop what they want the behavior on the edge. The second one is Node-RED. Node-RED is contributed by the IBM. It's kind of the logical design tool to help the customer to design their data from the input to the output. That is the kind of the graphic, the drag and draw tool, so customer can easily to develop that by the drag and draw. Okay, here is main objective for our edge intelligence server. First, we would like to have the equipment connectivity. Second one is the data virtualization. Last one is the big one, the predictive maintenance. Okay, here's more detail for our edge sense. Our edge sense, the main purpose is we aggregate many kind of the sensor data, then do some of the intelligence and the pre-process in the middle of our edge sense. Then we transfer the meaningful data to the cloud. Then there will be the machine to intelligent operation. Okay, so we have the 5 kind of the software application developed by the Advantech. First one is WISE-PaaS RNN, the remote monitor and the management. It has the device management console to help customer to manage the all kind of the device on the edge. And next one is OTA, over the air. When your device have the firmware, have the software, they need to upgrade. When they have the security issue happen, they need to upgrade. So as your Android, they always update. They use the same mechanism, so-called OTA. Okay. And the third one is I just mentioned that the voice agent is kind of a source code to help customer to integrate the source code in their device. And the next one is the security. We leverage the third-party solution to secure our WISE-PaaS, okay, and our edge device. Last one is the ESL, the electric, the shelf lab. It's kind of the electrical paper to show the information to our customer. But it's totally different with the WISE-PaaS. It's kind of a solution for our customer. Here's detail for the edge sense. I would like to go to in the detail. I will give you a quick review. That for our edge sense software stack, we provide the 2 kind of operating system. First is the Windows 10. Second is the Linux. Then there are a lot of software stack and IoT related application we have to provide our customer. And then for this one, it's the most important one is the orange part. This is so-called the edge platform or the cloud communication. This part is the major part to communicate with our WISE-PaaS and SaaS. Then customers can through such the framework to put their benefit or their application to our edge. Here is another the concept about our edge sense and the WISE-PaaS and SaaS. As I just mentioned, we aggregate many kind of the sensor data and many kind of the standard protocol. Then transfer their data to do some of the pre-process in the middle side, in the gateway, then transfer data to the cloud. But there are 2 major tasks that we are doing in the middle. First is the sensor data acquisition. We provide the two kind of our solution. First is the test link to communicate the hardwire, the sensor protocol, and the YCC to communicate with the wireless sensor protocol. Then such a data to transfer to our gateway, to our edge sense. We doing the data normalization and store the sensor data in the local side. Then we also provide the N2I and the E2I, machine to intelligent and the equipment to intelligent solution ready package. They will adopt the different inference engine to make their machine more smarter. The last one is NSaaS. NSaaS is provide the machine learning the framework to help the customer to train their inference engine, then put their inference engine to the M2I or the E2I SRP. And also our WISE-PaaS, our NSaaS, they have provide some of the facility to communicate with the business and our marketplace. Here is our WISE-PaaS, the NSaaS high-level architecture. As you can see that there are the data flow. There are the three data flow. First is the data producer. It comes from our edge side to aggregate many kind of the sensor data. So it's so-called the data producer. And in the middle side, when we get all of the data put under our WISE-PaaS and SaaS, so that is the data storage. Then customers throughout the API to get the data to do the more valuable application and the service. They are the data consumer. In the middle side, we put our WISE-PaaS on the Microsoft Azure ICE platform, ICE infrastructure. So we provide another solution for the private cloud solution. So we also leverage the OpenStack. And then we build the open cloud foundry on such an ICE platform, then leveraging the benefit such as multi-tenant, clustering, and the elastic scaling, high availability, and also IoT messaging hub to connect the diverse and huge device. And based on such the foundation, Advantech developed the database infrastructure. So we provide the data, WISE-PaaS data service. And we also provide a different kind of database. So we also develop the database management, identity access management, and also the multi-tenant management. Then we also provide the machine learning framework to help our customer to do the data analytics. Then we also have the API management and the billing management to help our operator to know what's going on for our WISE-PaaS. For this high architecture, I would like to highlight the most important one is the green one. Okay. We also developed the marketplace. The marketplace is to help our customer to purchase their application and their service from the website online. Then they can put their service on our WISE-PaaS. So we also build up our marketplace and communicate with our WISE-PaaS, and also communicate with the Advantech backend, IT backend service. Then the last one, the second one is the DevOps. DevOps is kind of the mechanism, okay? It's a set of the practice that automatic the process between the R&D team and the software development. In order that they can build, test, and release their software faster and reliable. Okay, that's the DevOps developer and operation. Okay, so I will give you the detail in the next slide. Okay, third one is the API and the knowledge. We also provide many kinds of the API and also provide the knowledge on the cloud to help a customer to easily design their application. And last one is the dashboard. I think the dashboard is the last mile for our customer or the developer to demonstrate what the result of their file to their customer and show the data analytic, the result, the trend for their customer. Okay. Here is detail for our WISE-PaaS. As you can see, as I just mentioned, the edge intelligence, we provide the three kinds of application on the edge. First is our web access. Second is the edge sense. Last one is the video sense. We provide the four kinds of the software to help our customer. First is the WISE agent, knowledge, to help customer design their application. Then we also provide the device management to help them to manage the many kind of the device on the edge. The last one is the protocol, the conversion. So we provide the sensor protocol management to help the customer to manage many kind of the sensor protocol. Okay. The second layer is ICE. ICE, we premium ICE provider is Azure. We based on the Azure. Then we also developed the Ali recently, and the Amazon is in our plan. We would like to put our WISE-PaaS in the different kind of ICE platform. Then we also provide the on-premise solution is based on the OpenStack. For our WISE-PaaS, as you can see, they have the six major components. First one is the IoT hub. We leverage the RabbitMQ. Then they can communicate the huge device connection. Then we also provide the three kinds of database. First is the Mongo database for the unstructured database, and the PostgreSQL for the structured database, and the InfluxDB for the time series database. But we need to develop the data management mechanism to help the customer to easily access such a database. Okay, and on this part, we leverage the Cloud Foundry and also leverage the benefit for microservice, elastic scaling, and the high availability. Then we also, based on the open source project, so-called OpenID and the single sign-on, to develop the user user experience, the login, the mechanism. Then we also develop the billing and the metering the mechanism to help our operator to easily to monitor how many usage and how many our past resources they have been the consult. Okay. The last one is multi-tenant. Okay. Then we also provide the visualization dashboard, the solution for our customer. First is based on the Grafana to provide our WISE-PaaS dashboard. And we would like to provide another solution, so-called the SaaS component. It's based on the third-party solution, the high tuple, and can help a customer to drop the equipment, the data flow more easily. Then last one, we provide the analytic service AI. We leverage the TensorFlow and also leverage the Caviar and the Onions. We also collaborate with the academic research to enable the GPU, to help our WestPass have the GPU the capacity. Then based on our WestPass, we provide the RESTful API and the Node-RED to empower our SRP and empower our end user. Okay, here is our WestPass, the debug process. I would not go detailed in each of the flow. I would like to let you know that they have the process we define the three major stage. First stage is the development. And the second stage is the system test. The third test is the operations. Each stage have their own test case, and then they will automatic test by themselves and will go to the next stage by some of the threshold. And in whole process, I will highlight this part. This part is the most important one, so-called the blue-green deployment. Blue-green deployment is quite popular for the mobile system. You might not know your application backend service. They have to update recently because maybe they have to adopt such the deployment mechanism. If your application they notify you, they need to shut down because their backend service need to maintain. They don't need use such the deployment mechanism. So what is the blue-green deployment? I would like to say that maybe you will see the predictive maintenance might be the monitor, the most expensive the equipment one. But actually, for the predictive maintenance or the prevent detection for the whole manufacturing operation, they might not be the expensive one. It might be the most critical equipment or critical parts. In the semiconductor, when they produce their semiconductor, they have their wastewater need to produce out. So they have to use the wastewater pumper to get the wastewater out. But when such a pump break down, the whole operation might be shut down. The whole operation shut down, the cost might not be the extent as the pump cost. The whole operation might be the $1 billion. The pump might be the 10,000 or the 100,000. It's totally different. And in the downtime periods, hold online the material will be waste. Okay. Okay. And why does AI grow so fast? Since a lot of the customer and a lot of the vendor they provide our PaaS platform, so the data is getting huge. So and the data is more easy to access. So that's the first step. The second step, in PaaS, a lot of machine learning they use the CPU to calculate, to make their algorithm more fast. But when NVIDIA, AMD, and Intel provide the GPU and FPGA, they can help the AI to to calculate more fast. Okay, and last one is the better algorithm. Since there are a lot of algorithms helping to contribute in the open source project. So the AI and data data scientists can get more better algorithm from the open source. And there are a lot of big name companies such as Google, Facebook, and also donate their algorithm in the open source. Okay. So let me explain that the journey of the AI between the wide path from the cloud to the edge. As you can see, there is the data flow from the edge to the cloud. We divide the three parts of this data flow. First is the edge sense, then transfer to the outward path. Then the data is collected on the outward path as solution ready package, or the application user can get the data to develop an application or to show out to demonstration to their customer or their boss. Okay, let me start it. First, the data since the aggregate from the sensor device to our edge device and stored to our local database. Then transfer to through the northbound, transfer to our widespread IoT hub and store to the time series database. And the data scientists would like to use such a data. They will put the data to the Hadoop for the better the performance. Okay. Then they training their pinpoint as the model, then programming such a model as the inference engine. Then deploy the inference engine to the edge side. So that's the first step for the AI. Then how does the AI running on the edge? Here, the sensor keeps the aggregate to our gateway device. Then through the southbound to our inference engine, and inference engine will see the sensor data is going bad or going where, and then we'll do some real-time action through our southbound to the sensor device. Okay. Then how the inference engine to upgrade, and how our inference engine the more accuracy. First, the inference engine and the latest sensor data keep the update to our wide path, and the data scientists get the latest data to tune the more accuracy the inference engine. Then deploy the inference engine to the edge sense, to our edge. Then the data scientist would like to show their analytical result to their boss or their customer to convince that their solution is good or not. So they will use dashboard to show out what the result they are. Then tell their customer the data is turning bad or turning good. Then the decision maker will make the action plan, then to refine all the inference engine to make all the AI operation more better. Okay, here is our IPC predict maintaining. Before I started the IPC predict maintaining, I have said for predict maintenance, there are the key components. First, we need to have the data scientists. Second, we need to have the domain know-how, and they're willing to share their data, and they're willing to tell you that the pain point, where's his pain point. The third, they need to have the PaaS platform to aggregate such huge data to do the machine learning. So from the Advantech perspective, Advantech is doing the IPC produced for the 13 years. So we have the domain know-how in the IPC design phase and the manufacture phase. That we get a lot of the data. So I'm the embedded system, the software leader. I know a lot of the data in the IPC design phase. So we find out the IPC have the 3 key components where influence, will affect the defect, will become the defect. First is power supply. Second is CPU. The third one is the storage. The 3 kind of the key components have the problem. The all IPC will be shut down or will be have the problem. So we aggregate a lot of the data to make our AI to predict our IPC. Here is a demo for our predict maintenance for our IPC, especially for the hard disk. Here, as you can see, we have the device management console, so-called RMN. So you can see in this device management, you can see the icon is so-called PMQ. In this system, there are the 4 hard disks. And you can see each of the disks, the health is good or bad. Okay, so you can see there are 4 hard disks in this system. Then you also can see the health, the historical trend, and also he will give you the forecast in the next 4 hours. Okay, based on the list of data, then it can give you the predict maintenance. Okay, then we can choose the back hardy. They can tell you the health score is quite bad. Then they will give you some suggestion to tell you how to do it in the next. Maybe you need to back up your hardy, or you need to shut down the system. Then the next one is this one. We also have the inference engine version, and then here's the accuracy, the rate, and you also can deploy the latest or new inference engine from this part. Okay, another AI example for our manufacturer is so-called AOI, the automatic article inspector. In the past, we hired some of our workers to use their eyes to fix the ability to find out the defect. To find out the defect like this one. They maybe one day only can find the 2 or the 5 defects for each of their work time. But we engage some of the research, academic research, to enhance our AOI to find the defect by the AI. So the accuracy I see is about 95%. But it's not mean that we don't need the worker to do such a thing. It just helps our worker to do such a thing more efficiently. Our workers still need to review the defect AI found it, and they need to find some of the defect AI did not find it, and update such a data to the AI to make the AI more accurate and more perfectly. Okay, so here is our Internet of the Thing, the demo site. We have the construct ready in the 2016. First phase, we have a lot of the latest IoT solution in our phase 1 building. Then we have the phase 2 building have been ready and also demonstrate the industrial 4.0 the concept in our in our factory. So as you can see, our factory, this is the industrial 4.0 situation. Our manufacturer leader, they use such a situation for the weekly meeting and to know what the data is critical, and find out what plan in the next they need to do. They need to optimize their operation and produce the flow. Okay. Okay. So welcome you to visit the demo room or our Lincoln building, and if you have the interested in the visit our building, you can contact our HR. They can give you the professional guide tour. Okay. Okay, that's all.
So, do you have any question before ending? Your time is limited. We are open for one question.
Could you provide an example related to the practical application of IoT that Advantech is working on in present industry?
So can you be more loudly? Loudly, yeah, it's very hard to hear.
Could you provide an example related to the practical application of IoT that Advantech is working on in present industry?
You mean the example, right? And for the industrial or for the IoT. And I see we have a lot of IoT solution, but it's not the comprehensive and it's not complete for the IoT, because we need to have our solution integrator based on our solution ready package, and to integrate the customer application to make the IoT solution more complete. So Advantech is not to provide the fully the solution for our customer. We provide like a turnkey solution, maybe the ready for the 80%, and the last 20% maybe need a customer to develop by their demand or by their application. So Advantech have the IoT solution in our manufacturing. So that's what we see Industry 4.0 in our the factory. Okay.
Okay, I think that's really a good example about how to use IoT in the industry. And before the ending, as you know, next week we will go to Lincoln to visit the demo part, as you just show on the slide from the booth. So I think you definitely will see it next week. And remember, at least 2 or 3 people need to bring a laptop to really practice IoT and get help from sensor layer. I think that's quite exciting. And so before the ending, I want to say, I think Luis will stay here for a while. So when we finish today's talk, if you have some question or you want to know how to develop your good project, please come here, because Luis already gave me some good idea about using IoT for farming and aquarium, and also for the small size manufacturing. Actually, he just gave me a lot of ideas before we talk, so I think this can benefit your good project. So let's give a big applause to Luis. Thanks for his good talk.